Columbus was a dummy. You may have heard that nobody wanted to sponsor Columbus' expedition because he thought the world was round, but that isn't true. Even the ancient Greeks were well aware that the Earth was a sphere in 300 BC. The real reason why nobody wanted to sponsor him was because they thought he and his crew would die of starvation and disappear at sea. Why? It turns out Columbus made a pretty big math error. He believed the size of the Earth, or its circumference, which is the length of its equator, was much smaller than it actually is. He figured the distance between the Canary Islands and China was 4 times smaller than in reality. Contemporary geographers knew China was simply too far away to be reached by traveling west, as ships at that time couldn't hold enough supplies to sustain such a long voyage. So, when Columbus tried to convince royal courts to sponsor his voyage to China, he understandably had a tough sell to make. But he was very lucky to discover America, as otherwise he'd probably be a nameless nobody who starved to death at sea. Ironically, the same Greeks who knew the Earth was round also calculated the Earth's size to within 1% more than 1,000 years earlier, using only sticks, feet, and some math. That's right, no telescopes, astronomy, or great journey. In 200 BC, Eratosthenes, a Greek librarian living in Alexandria, Egypt, decided to do a little math. He had heard tales of a famous well in Syene, a border town in the south. At noon on the summer solstice, the sun's rays shone straight down into the deep pit, illuminating only the very bottom, and not any of the sides, which meant the sun was directly overhead. This was an intriguing tale, and things like this might explain why summer solstices held great religious significance in many cultures. But Eratosthenes was more interested in using this fact for a great experiment. First, he hired a bimetist, a specialist trained to measure distances by counting their steps. He had the bimetist measure the distance between Syene and Alexandria. Then, at noon on the summer solstice one year, Eratosthenes hammered a rod into the ground and saw that it cast a shadow, meaning that the sun was slightly south rather than directly overhead like in Syene. His next step was to find the angle of the shadow, which he did by recognizing the stick and the shadow formed a triangle. Next, he used some trigonometry. Using the tangent function, which is the side opposite the angle, in this case the length of the shadow, divided by the side next to the angle, in this case the length of the stick, he found the tangent of the angle. He then took the inverse of that function to find the angle itself, which required a little bit of research because in those days, calculators didn't exist. Now I know that seems obvious, but it meant that calculating complex values was difficult. To find his inverse tangent, Eratosthenes had to look through tables containing lists of trigonometric functions for different values, and look for values of tangent functions that were closest to his value. After more than a bit of trigonometry, he found that the angle of the shadow was about 7.2 degrees, or 1/50th of a circle. Next, he decided to draw a circle representing the Earth, with lines representing the sun's rays and the cities of Syene and Alexandria. He noticed that the sun's rays formed 2 parallel lines, with Alexandria's line acting as a transversal. That meant the angle of the shadow Eratosthenes measured in Alexandria was equal to the angle formed by the intersection of the radiuses of Syene and Alexandria. This part of the circle, called a sector, is 1/50th of the Earth, since the shadow's angle, called the central angle of the sector, is 1/50th of 360. Therefore, the length of this sector has to be 1/50th of the Earth's circumference. And luckily for Eratosthenes, he had already measured this distance. So, to find the circumference of the Earth, he just had to multiply the distance from Syene to Alexandria by 50. While he was at it, he found the radius of the Earth, given that the circumference is 2 pi times the radius. Using a very rough value of pi, he found the radius with an error of only 0.1%, while his value for the circumference had an error of about 0.4%. Remarkably accurate considering he didn't have to use a calculator or a telescope or anything other than feet, sticks, and some geometry. Guess Columbus should have paid attention in math class. It just goes to show you, you don't need fancy technology or sophisticated gear to do something. You just need a little bit of math and history.